So welcome everybody to our fourth webinar from our series of next-gen materials. We are going to be waiting for a couple of minutes for more attendees to be able to join, and then we are going to kickstart with our session for today. For the people that are joining right now, we are giving some extra 2 minutes before we start, so more attendees can join, and then we are going to move forward. All right. So before we move forward, I need to inform you that this session is going to be recorded. It is done so afterwards we can share the recording through our social media accounts. So everybody who would like to learn a bit more about the topic of today will be able to access this session at a later stage. My name is Ellie Shtereva. I am a project manager at F6S, and I'm going to be your host for today. Today's topic, circular materials and digital traceability, building a sustainable future for EU manufacturing. Um, Before we delve into the topics, and we have some excellent speakers here with us so they can educate you a bit more on life cycle assessment, analysis tools, and what is out there as digital solutions to be able to support you in these practices. Let me give you a bit of an overview of what we're doing here and why these webinars are happening in the first time. So, our webinar for today is part of a larger series of webinars titled Next Gen Materials Europe's Digital Manufacturing Leap. And they are co-organized by three EU projects, DiMAT, PIONEER, and Manufacturing. We are doing this because all of the projects are extremely focused on the development of digital solutions for advancing small and medium-sized enterprises economic boost through the adoption of digital solutions for enhancing their processes. Specifically for the topic of today, circular materials and digital traceability, we're going to focus on two main aspects: life cycle assessment, how this is performed, what are the tools to be performing it, and what are the key parameters to be having diligent and adequate data assessment for your different procedures in terms of sustainability and circularity. And also we're going to touch upon the topic of digital traceability on how you're following the different processes of your product from the very beginning, from the extraction of the resources to be creating your product till the very end, how this can happen to digital tools, and what are also the benefits both for the company and also for the customers in order when you are applying this diligently. Regarding life cycle assessment and digital traceability, of course, there are a lot of benefits on adopting this. This is a very hot topic for the European Union, but also globally, considering the pressing need of adopting circular and sustainable practices in order to maintain our resources and well-being. By adopting life cycle assessment methodologies and tools, the companies are gaining very obvious benefits, both for their economical productions, but also for their internal processes, such as enhanced customer trust and brand reputation. As you know, this is something that more and more is becoming very prominent for the customer choices when they are searching for products and are looking for the quality and the source of those solutions that they're looking for. Improved quality control also reduce waste from the company's part, which is also supporting the enhanced and costs, reduce costs for the companies, meeting regulatory compliances. This is something that is becoming very stringent in the European Union. And of course, last but not least, better risk management and supply chain resilience. As I have mentioned, this is a very key focus for the European Union. There are two main programs that are dealing with this, the Digital Europe program and the European Industrial Strategy. And a lot of funds coming from the European Union are targeted specifically for developing such solutions to be supporting the European industry going in this direction to be more sustainable and more circular to the development and to the adoption of digital solutions. And as we know, this is something a bit more complicated for smaller companies in order to use the digital solutions, pay for them, and also speed up and align with the larger competitors that are out there on the market. As an outcome of this application and adoption of the digital solutions that are currently available, it is expected that a more agile, efficient, and resilient European industry can be achieved. Regarding the different topics, and as I have mentioned, we are developing and sharing with all of you those webinars so we can build a better knowledge base for the companies that are interested to adopt such solutions and also for you to know what is out there and how to be using it. We have gone through several topics that are pertinent to this larger field of digitalization of the European industry. And we have started with the role of digitalization in advanced manufacturing, which was provided on the 20th of May. Then we followed up on the 27th of May with the topic of standardization and data management for material manufacturing. On the 5th of June, we have focused on digital tools for accelerated materials discovery. And today we are focusing on circular materials and digital traceability. We have one more webinar down the pipeline, which is going to be delivered on the 3rd of July. And we're going to be focusing on a very hot topic as well, which is the digital twins and AI within material manufacturing. All of the sessions are recorded and will be made available as well through DiMAT YouTube, through our LinkedIn accounts, but also you can go to Manufacturing and Pioneer, also distributing the webinars. Today, in the presentations that we're going to share with you, we're going to be focusing on materials and environmental and cost lifecycle assessment. This is going to be delivered by Draxis. And then we're going to move to opportunities and difficulties of applying LCA on the digitization of manufacturing processes. This is going to be delivered by IRES. Before we delve into this specific topic of the two presentations, we're also going to have a discussion with several questions asked to our speakers to get a bit more information specifically on the life cycle assessment field. So without further ado, and before we start with the session, let me introduce you to our speakers. We have Thanasis from Draxis and Konstantina-Roxani Chatzipanagiotou from IRES. And for myself, I already told you, I'm Ellie Shtereva from the F6S Innovation Team, and I'm going to be moderating the session today. So regarding the discussion, let's delve to the questions. My first one is directed to Thanasis, and if it's possible to give us a bit more information on what is life cycle assessment for companies and what is the process behind it. Is it easy for a manufacturing company to be applying this process and estimate their carbon footprint?
Thank you, Ellie. Hello, everyone. Nice to be here. So let me start with this first question and trying to keep it simple. As you may have heard, maybe the LCA methodology is generally applied when we want to assess the environmental impacts of a specific product or a process or even a service, and to have this analysis throughout its life cycle. This is why, of course, we call it life cycle assessment. And what we mean when we say life cycle, we can start to have our study and calculate our impacts for various stages of this product, starting from the very raw material extraction point and reaching to an extent that we might want to have for the study. This means that we can include the manufacturing stage, the transportation stage, and of course, even the use stage of a product or even the end of life of it, so the waste management. This is a methodology that is based nowadays on ISO standards. Since actually 2006, this methodology have been standardized based on ISO 14040 and 14044. While we can see, this is for your information, we can see that the first life cycle assessment was actually conducted in 69 by Coca-Cola, but it passed like 37 years to be officially standardized methodology. It consists of 4 stages. You might have heard also stages, the goal and scope. Here is why we define why we're doing this, and we set the boundaries of our system. And the unit that is a reference, based on it, we collect data and we present the results. Then we have the inventory analysis. So based on our needs, we collect data that we need for the calculations. Those data mainly refer to raw materials used in a product system or energy, waste generated. This is inputs in our system, let me say. And there is the output, of course, that is waste generated and emissions to air, water, soil. And then it's the calculations. What we mean is that we translate this data into impacts using methods that are now established, that they have actually factors that do this translation. And then it's the interpretation of the results. And yes, of course, there are nowadays various tools and databases to assist this process. It's not that you need to take an Excel and start putting all these numbers in there to do that. But we will talk also further about this. Now, if it's easy to do it, and we are focusing, as I understand, more to carbon footprint here. Carbon footprint, just to clarify, is more specifically related to tracing the greenhouse gas emissions throughout a value, about the stages of a life cycle. And so I would not say that it's quite easy, meaning that on the one hand, it's complex, meaning we have various stages, various emissions that we need to consider, direct emissions, indirect. So in my opinion, that those would need firstly to be done by people that have the expertise and the some degrees, let me say, that they are familiar to these processes. And of course, that to have the necessary assistance with the tools, as I mentioned, because it's quite difficult to actually go into trace backwards for where emissions come from. So that's why databases are, from the very beginning, were established, and nowadays they are used. And just one last thing is that the most basic for me would be data. So tracking data, compiling it efficiently, this would be one of the most basic things to consider. Yes.
Thank you for this. Indeed, I think also in your presentation, we're going to see one of the digital solutions that can bring closer companies that don't have the expertise in LCA to understanding better how they can do it, but still they would need this internal expertise to be available to analyze all the data that is available. So indeed a very complicated process, but still manageable, and getting even more manageable now with the digital solutions that are available, and also very important for companies nowadays. Okay, and then building on this, Roxani, can I follow up with you on how can understanding the full environmental footprint of our materials and processes guide our circular economy efforts and create sustainable advantage for the EU manufacturing environment?
Yes. Hello from me as well. Thank you for this question. So I would almost say that understanding the full environmental footprint of a production process or of a material is necessary. We cannot go towards circular economy if we don't understand that. That might be a very strong statement. So I would say that it makes our life very much easier to the very least. So it is, in my view, it is essential to guide circular economy efforts. Understanding the full environmental footprint can help us identify hotspots, either of use of resources that have very high impact to a certain manufacturing process or a certain product, of emissions, of waste generated. So it is very important to have a good view of which materials and which substances contribute significantly to a certain process along the life cycle of this process. This allows, of course, companies to make smarter design choices. So, for example, to select specific alternative materials that have less impact, or select the waste treatment process that results in lower environmental pollution eventually of the residual materials that remain after it. It is also very important, and I think that is one of the advantages of life cycle assessment that we really cannot stress out enough, and that is that it prevents problem shifting. So you can have a process and you can create a process that you targeted specifically to limit, for example, the greenhouse gas emissions for the production of a certain material. And this is amazing. It's very important, and on a European level, we have a lot of regulations specifically to target climate change. But what if this process that you design, the way that you perform it, has a significant impact in another impact category? What if it uses very toxic substances? Or what if it requires very rare materials in order to run this process? So it is very important to apply the life cycle assessment methodology and to take into account this holistic view that LCA includes, to take into account multiple impact categories, so you can understand for every environmental compartment, for every type of environmental impact, what exactly is the impact of your activities, and whether you are just shifting the problem to another life stage or to another impact category. So I think, having a view of the full environmental impact is very important also from that perspective. Of course, understanding how material flows along a value chain enables the reuse of reclaimed materials, also within the same industry, but also over different industries. So you can turn the waste basically of one manufacturing process into an input for another. And this cross-sectional circularity is very important, and it requires some recognized sustainability certifications, so that there is trust from one industry to another, and there is transparency that this material that I'm going to receive has certain sustainability certification, that it is what I think it is, and that eventually my carbon footprint for using it is the one that I aim to have. So I think, having a European-wide understanding of the environmental footprint can facilitate safe and efficient exchange of materials and resources across manufacturers. So certification and trust is important, and it does not only benefit one manufacturer or one sector, but I think on a European level it can create a lot of interesting synergies and enable material exchange and knowledge exchange over different sectors. So this could benefit the European industry as a whole, and therefore the economy. It is, of course, important to close resource loops, and also within Europe and on a global level, but for now we're focusing, of course, on the European industry. There is also a lot of sustainability regulations that small, medium enterprise, larger enterprises need to adhere to. So this is another reason why it is very important to have a good view of our full environmental footprint as a company. So this at the end will give a true sustainability advantage to industries, either for regulations that are now in a voluntary state still. So some initiatives within Europe right now are not mandatory, but we can predict that they might become mandatory in the future. For example, the climate change impacts. So the climate law is already a requirement for companies, and we can foresee that other aspects of sustainability might also become eventually. So it's also good to be ahead of the curve in that sense for companies. And these efforts will not only support, of course, the environmental goals that we set, either as a company or as a European Union overall for our industry, but also it can enhance the economic resilience and the global competitiveness of European industry, which I also think is very important to understand that sustainability is not just about environmental sustainability, but there is also an economic and a social aspect that are also very important to stress out. So I think I covered this question. I think indeed it is very important to understand our environmental footprint if we want to move forward towards a circular economy.
Thank you, Roxani. Indeed, a very good overview. And I want to bring you back to two very important aspects that you mentioned, and I'm going to give the floor to Thanasis with that. But first, it's about the not missing any detail while you're doing your life cycle assessment, because if you don't have the really all the processes detailed and calculating everything, you are omitting something, and the whole calculation at the end of the day might be wrong. And I also remember back in the days, like maybe 7 years ago, we were doing these calculations with startups, where startups needed to do the LCA calculation for themselves. They were provided with data, with a lot of data to be tracking the different processes and what are the carbon footprints on that. And there was the man factor involved. So if they miss even one, which is obvious that they will do, then the whole calculation is wrong. So Thanasis, just a question for you regarding the LCA tools that are available now. How reliable are they for all the processes to be calculated in the proper way to get adequate results at the end? And how can companies such as SMEs use them?
Thank you, Ellie. Yes, as nowadays we can see that various tools, let me say in this case, softwares and databases that are importing these softwares. The most commonly that we can hear are CIMA-Pro, OpenLCA. Those are, for example, names that are considered professional and commonly used, so you can see it in various studies. So, in general, they are considered reliable in an extent, but of course, this is related to if used correctly. So, firstly, as I mentioned before, you need the scientific knowledge. So yes, you must have the expertise to do that. Secondly, of course, they are not, let me say, perfect, but they might have some uncertainties during the estimations. But sometimes this depends not to the tools themselves, but for example, I'm going to have a study, and firstly, the quality of data. Is it precise? Is it an estimation? Are they literature-based? Can you provide them? Etc. So data is another part. The boundaries of your system that you are going to examine. The rule says the wider the boundaries of your system that you are examining, of course, you get more need for more data, more uncertainties, and so the story goes on. And this, of course, will lead you to assumptions if you have wider, for example, boundaries. You need to do assumptions that may sometimes oversimplify things. So you get an uncertainty point from there too. And sometimes there is the issue of the databases that they have gaps and sometimes outdated data or more regional data. For example, some databases say that this express, for example, the technology of this period, but you may have evolved further, and so the data are not too accurate in your case. and etc. And let me say, in the case of SMEs, sometimes in order to get their footprint assessment, let me say the sustainability assessment in general, some of these databases are sometimes costly. So one SME, for example, might consider purchasing the database or going to people, consultants or practitioners that they will do the analysis for them. So this is another point. Now, the companies can use those assessments, the LCA, for example, for various reasons. The most common is that you want to design your product more, of course, in a more sustainable way. So you are going to have a hotspot analysis, you can compare different scenarios, and you can understand, for example, what is more environmental profile for your product. But this is not just related to, for example, inside the factory. You may consider a supply chain optimization, transportation. You provide the raw materials from where, and so your decision might also consider this part. And of course, LCA can be used for other reasons too. For example, sustainability reporting. You can have ESG reports or product labeling. You can have just regulatory compliance, for example. And I would also add the branding part of this. So it would be good for a company to add the value and have environmental metrics on the product. So one consumer can, for example, compare. So that would be from my side.
Thank you, Thanasis. And building on top of the process and the analysis and how wide it is, there are certain approaches, right, to LCA. And
Yes.
as terms we know, cradle to cradle and cradle to grave. And I think there's actually a third one, if I remember correctly. So can we have a bit of a discussion with both with Thanasis and Roxani on, first of all, what is the difference between those two approaches? Because I can imagine that not everybody is aware on what is different and what do they mean. And is there a better approach, or it really depends on the processes of the company on what they are going to be focusing at? So whoever wants to start first, please just do it.
Please, Roxani, if you want.
Yeah, so yeah, to start with a bit of a definition. So indeed, in LCA, you can approach a manufacturing process with, you need to frame it in certain system boundaries. So that could be, for example, that you start from cradle until gate. That would be a simple one. So in that sense, you start from the raw materials, you take into account the extraction of resources from the environment, and you stop with the production of the product that you care about. So you don't look at the use phase, you don't look at what happens at the end of its life cycle. You only focus on the manufacturing process of the product itself. You can have a cradle to grave approach where you again start from the raw materials and end up the waste treatment process that can be landfilling or incineration. So it is it more aligns with the traditional linear model of material production, of product production. And finally, we have the cradle to cradle approach. So this is more aligned with circular models. So here products are designed for with a main focus to have the final waste not be a waste, but to actually be something that can be reused and reintroduced in the manufacturing process. So this is more for, as I said, a circular approach, a zero waste approach to analyzing systems in LCA and to viewing production processes in that sense.
You might have heard that circular economy have like 5 R's. I don't know if you have heard it, like the 5 R's of circular economy. So like reducing, repairing, and recycling, etc. So as Roxanne said, this is more granted. For example, I'm going to the cradle-to-cradle approach, this is more towards applying the circular economy rules in this approach. And I agree to the part that in this cradle-to-cradle, it's not about just managing waste, it's just considering that waste doesn't exist, like nature doesn't consider something as waste. But yes, it proves, but as you said earlier in your intro, it's not about what's better, it's what is your purpose of your study, for example. There are many. It depends. Yes,
that is important to point out, and I think it also very well aligns to the answer to your previous question, that the more you expand your system boundaries, the more uncertainty you introduce. So at the end of course, it is nice to have an approach where the target is to eliminate waste. No one is disagreeing with that, but whether you have a reliable result at the end of the day, because you super much expanded your system boundaries and you introduced a lot of uncertainties where the client that hired you to do an LCA or the project that you're working on might be focusing solely on, I will replace material A with material B in my manufacturing process. So then why would you even make the effort to apply a cradle-to-cradle system boundary? You could even say a gate-to-gate in that case would be sufficient. Yeah, I totally agree. It really depends on what outcome you want to get, and your goal and scope basically of your study will really determine what approach you need to apply. Yeah.
Just to add something, it might, in this sense, exactly in that sense, actually, it, for example, an SME that is trying, it starts to track its environmental footprint. It might prove more practical or even more simple to go at a cradle to gate or cradle to grave, for example, approaches. It could be more practical for a start, let me say. But even though cradle to cradle would be something that as a model would be environmentally more friendly, it would be more complex to be applied, but still preferable. Yeah.
And there is also some criticism, if we're being honest, on the cradle-to-cradle approach. So as far as I understand, at least based on reading literature, I don't have hands-on experience on that, but typically a common type of criticism is that it tends to ignore the use phase. It focuses way too much on the manufacture and the design towards zero waste, and it might downplay a bit some other aspects of along the value chain. The use phase is one of them, or whether we have sufficient renewable energy, for example, to power these very ambitious zero waste manufacturing processes that we want to approach, or whether a closed loop system is easy to upscale, for that matter, because our know-how as not mine personally, I'm not an industry person, but as a whole, I mean, in industry, we have a lot of experience on dealing with linear processes, and of course, circularity is important. Of course, closing loops is important, but is it feasible to scale that up to the levels that we need to cover our needs for some processes? So it is nice, but we need to take it, I think, with a grain of salt. That we need to make sure that we know how to apply it, that we don't miss important parts of impacts or life cycle stages, and we don't end up greenwashing some manufacturing processes for the sake of circularity, while shifting the burden into other life cycle stages or other aspects of the material production.
Thank you both for this thorough discussion. I had more questions, but I think we need to move to the application side and the solutions that are being developed for this topic. So now we're going to move first to Draxis and Thanasis. He's going to be speaking about the life cycle assessment tool developed under DiMAT and how companies can be using it. So Thanasis, the floor is yours.
Thank you, Ellie. So, can can move the slide. Yes, it's just a quick overview about, as you may know, DiMAT project develops various digital tools. You can see that actually targeting to each stage of the material value chain, for example, the design phase, the manufacturing stage, etc. And they are targeting to improve the quality, the sustainability, the effectiveness, and the competitiveness of materials. As you can see on your left, there's been a development of 3 suites, as we call them, and each suite consists of 3 toolkits. In our case, MEC-LCA is a part of the first suite, and MEC-LCA actually, as you can see, means materials environmental and cost life cycle assessment. Next, please. Thank you. And as the title says, it's not about environmental assessment. It's also about cost assessment. So there is a life cycle assessment methodology, but this is one part of the sustainability, let me say, aspect. There are also the social and the economic. So in MEC-LCA, you can see the environmental and the economic aspect. So what this toolkit does, it actually uses all this knowledge and the applied LCA methodologies to give dynamic insights in environmentally and financially and support decision making. So this, as we have discussed earlier, one needs to have, for example, expertise for the LCA, but the toolkit itself is designed for easy interpretation of the results. So good graphics here play a critical role, and the toolkit has this part in a good representative way for the users. And so no special, for a user specifically, no special equipment is required. And moving on. So in the context of the project, we have 4 pilots that those toolkits are deployed. In the context of this presentation, I'm going to show you an example of one of these pilots. I'm going to, for example, show you pilot 3 that has to do with bending glass and how the toolkit using all these LCA results is useful. I'm not going to extend to the economic part, just the environmental part. So next, please. So, and considering all these discussions that we had earlier about this whole procedure, how data and having the analysis of good quality and what are the necessary steps. So considering the first phase, what we did for this pilot, as I mentioned, this is about bending glass. And here I'm just for, let me say, confidentiality issues, I'm going to generalize it, don't need for specific data. But now, bending glass, as I mentioned, this product system has to do about the baseline scenario. So that means that this is a situation before deploying the DiMAT toolkits to see how this is affected. This is something that is actually being driven right now. So no real data, final data are produced, but the baseline situation is produced. So here we can see, for example, that we target the design phase of bending glass, and as a baseline scenario, we consider that before the best prototype of a bent glass product is ready, there comes 10 trials of designing. So and we end this, as you can see, the cradle to gate here, as I said. So use states and end of life are not included. So that was the goal and scope that we sent the purpose and of our study. And based on that, we moved on the second phase of the LCA, which is the inventory analysis. The next slide, please. As I said earlier, the inventory consists of inputs and outputs. So we collected for all the processes of our product system, we collected data regarding materials used, energy used. When I mean energy, this could be electricity, it could be heat, any form of energy. And all the outputs were emissions during the processes and waste generated. So for example, in the design phase, it's glass that was not good was considered waste and went for treatment. So here, let me point out again those points that data collection is very crucial. So in our case, we collected primary data from the pilot, but also secondary data is necessary to conduct the full analysis. So in that case, this is a crucial part too. We used a data set, so we used a convent data set. And during this, of course, procedure, a good communication with the pilot was established. This is, in my experience, very crucial in order to get a good understanding of what you are studying, the processes involved, and in order to get a reliable and of high quality data. And of course, collected data can be done with several ways. For example, we use simple Excel files, but very useful in our case and very practical. So those data, you can next, were used by a software. As I mentioned before, we used OpenLCA software and the environmental footprint impact method to conduct the analysis. And so what information can, for example, the pilot get by seeing those results? It's, for example, here is something that's quite obvious by seeing it. We have the three main processes of the product system, and we have like 25 impacts here, different impacts. One can simply understand that the third process, the one that's with like yellow color, is the main contributor to all of them. So that simple, for example, optical figure can give a very good sense of what is the highest contributor to all impacts, and where the focus should be given to mitigate environmentally these processes. So next one. We can dive in further to an analysis and get more information. So to start making, for example, changes to get a better product system, it would be too complicated. So here we had a weighted results analysis, meaning that we are focusing on seeing which are the most significant impacts. So all these results that you saw earlier pass through a process that calls normalization and weighting, and you get the highest impacts, meaning in terms of significance, let me say. So you can see that 4 of them are the most significant, the highest: the climate change, the eutrophication of fresh water, the energy resources, non-renewable, and the material resources, metals and minerals. So focus is given for the analysis, mainly for what, in terms of what information can be used from the pilot, let me say, what is the most critical. For all those 4 processes, you can see in the figure on your right that the third process, the one with gray, contributes to more than 90% to all of them. So more focus, for example, here can be given in this third process. And the next slide, please. And if you want further analysis, you can see that this process consists of other sub-processes, and for example, sub-process 1 here in all of them is the main contributor, mainly due to electricity consumption, if you have further analysis and see it. And the analysis can go on and make viable insights, and where the focus can be given to make it your product system more environmentally friendly. This way, you can understand where your focus can be given. Yes. Moving on, and here are I'm moving on from this pilot I saw earlier, and here I'm showing you, for example, an indicative figure on how this can be shown on the MakeLCA toolkit. And for example, what we expect also to have for an after DiMAT scenario, as we call it, to see the results after the toolkits are implemented. Here is, for example, an expected outcome of another pilot. But of course, this is an estimation at the moment. And for example, here valuable information can be provided. As you can see, we can have here an impact of climate change. You can see for the product system that you have information for all the sub-processes involved in this product system. And you can see how which one contributes more and how each one of these is affected by the implementation of the DiMAT toolkits, trying to, let me say, minimize the design trials of the product, or this, and subsequently to reduce electricity consumption, raw material consumption, and even waste generated. So if this is achieved, you will get also a minimization of the respective impacts. So yes, that would be it. Just to conclude and to link also again with what we said previously, in order for an SME, for example, to get such analysis and valuable insights, I'm again pointing out the necessity for the availability and the quality of data, as well as the need to have someone to do the analysis with an expertise. In order for the analysis, of course, to be reliable and not oversimplified. And of course, the SME can use this. The analysis can be conducted with one with expertise, but the usage of the information would be simplified with the MakeLCA toolkit. So on the other point, one can easily access and interpret the results. And yes, so let me leave it here.
Thanasis, thank you for this presentation. So can I try to wrap it up about the MakeLCA and how, if I'm a company, let's say, how can I use it? So basically, I can use it both through the DiMAT platform as a cloud service. Can I install it locally in case I wanted to have it in my own servers? Is this possible?
One can use it, yes. One can reach out to us actually, and yes, conduct the analysis, and then he will get the results in the MakeLCA toolkit to have the, yes.
Okay, and then for the toolkit, from what I understand, so if I'm a company, I input all my data, but I don't know how to do the analysis. So the experts behind the toolkit, such as Draxis company, you're going to do the hard work for them. You're going to do the analysis, and then through the toolkit, they're going to get it in an easy to read and understand form. So they can, although they are not experts, they can take the right decisions in terms of their processes, operational businesses, and so forth. And this is how MakeLCA can support and facilitate their job. Okay, awesome. Thank you, Thanasis, for this. Now we're moving to Roxani and her presentation from the PIONEER project. Roxani, the floor is yours. I will stop sharing my screen.
Yes. I think now you should be seeing my screen in presentation mode.
Perfectly, yes.
Yes, okay. So I will walk a bit fast through my slides because we don't have that much time. So I will briefly explain what is the aim of the PIONEER project. It is to develop an open innovation platform and a digital pipeline which will connect various technologies in order to optimize the design of industrial systems with simulations. It has several objectives. It wants to support the transition for small, medium enterprises towards industrial digitization, to design digital tools for industry and enhance the efficiency and product quality, and increase the capability for better and faster reaction to market changes, changes in market demands for products. It aims to contribute to develop an advanced material modeling solution for specific industries. It aims to enhance data interoperability and create a new type of service for industries, which relates to data analysis, simulations, and visualization techniques, and enabled multi-directional data flow throughout the material value chain, which of course links to digitization of production and LCA. It will apply these solutions in 2 use cases. So one of them is regarding the construction sector, where we will investigate metal additive manufacturing. It will utilize hybrid construction, which will combine traditional old steelwork with additive manufacturing in order to add features on conventional I-section profiles of steel structures to improve their efficiency and load carrying capacity. Besides I-beams, I-sections, it will also focus on trusses. So there we aim to create trusses that have complex shapes and manufacture them in a way that saves time, lowers costs, and decrease the material use. And overall, basically, in this use case, our aim is to increase the load carrying capacity of these steel structures by a certain large percent, via increasing only via a certain small extent the material use, the added amount of material needed to construct them. The second use case where we will apply these digital solutions is in the automotive sector. So here we aim to develop lightweight suspension control arms consisting of composite material as opposed to aluminium, which is the standard usually currently. And here again, our main aim is to result in mass savings, so to decrease the weight of these materials, which of course will decrease the fuel consumption during the vehicle's life cycle, etc. So that is a positive thing. We will, we have defined the golden scope of our LCA and LCC study in this project. So the reason for carrying out the study and the intended applications. We aim to identify hotspots of environmental and cost impacts of the conventional manufacturing process of conventional I-beams or the conventional aluminium suspension control arms. We aim to compare the environmental and cost impacts of the conventional and the new processes that we will test in the demos. We have several ambitions and key performance indicators in our grant agreement that we aim to verify, of course, via the LCA and the LCC analysis. This relates both to the comparison between the conventional product and the new product, so the aluminium and the composite suspension control arm, for example, but also we have ambitions related to the application of the digital solution to the manufacturing process itself. So we are not just going to make a composite suspension control arm, but we are going to make it better and more efficiently. To put it simply, we have several ambitions also related to that. And we will create public data sets at the end of the project with LCA data, so that can be used for benchmarking against competing technologies. I will now discuss a bit along the scope of the LCA and more specifically the system boundaries that we have applied. So we start from the raw materials. There is an upstream process to create the input materials. So let's say the aluminium that you need to use to create a suspension control arm. This enters the manufacturing process where you create products, obviously. These products are used for a certain amount of time. They reach the end of the life cycle. Potentially, there is some recycling, so some recovered material might be regained and re-enter the manufacturing process. And there is, of course, transportation and packaging that needs to be considered along the life cycle. Our approach, our system boundaries are cradle to grave. In this project, and looking more detail into the manufacturing process, because this is the one that we focus on. Typically, a new product starts with a conception of the product, so someone comes up with an idea of a new product. They would create physical prototypes, they would test them, they would realize, okay, this is not perfect, let's go back to the manufacturing, the conception and redesign the product. And you do this a bunch of times until you are happy with the result, basically. So then after that, you move to large-scale production where you make products. Of course, not everything is perfect. Some of the products you create inevitably will be defective, so you need to get rid of them, to send them to waste treatment, and the ones that are of good quality enter the market. So the time to market typically for a new product is the one I saw here, starting from the product conception all the way until the marketable products. So in the PIONEER project, we aim to apply virtual engineering solutions. So we aim to have less material waste at the start of the product development process. Based on these virtual engineering solutions and these modeling approaches, we aim to have less time for a new product from conception to production. Ideally, we will prevent defects by these modeling solutions that we apply in these digital solutions. So yeah, there will be less waste material along the manufacturing process. Products will be created in a way that, yeah, with a small increase of material, we get a much higher increase of performance. So, we will improve the functionality, let's say, of the products. The time to market, of course, as you can also see visually in this scheme, will be shortened. And of course, it's not all benefits. There is also some things that we need to take into account that add extra resources to the project. So we need to take into account the infrastructure and the energy needed for this optimized process and to run all these models and all these simulations. Typically, the lifecycle inventory data collection file that we would send, also we use an Excel file as previously shown. It would include questions related to the functional unit, the reference flow. These are jargon related to LCA, so we don't need to go into too much detail about that. So we would ask questions about that to the project partners. We would ask them to explain to us what their manufacturing process and the value chain of the product look like, more or less. And then we would have a lot of questions. Usually partners are not happy when they see these many questions related to all the input materials or all the input infrastructure, the energy, the packaging, the transportation, the emissions, and the waste. And because we're doing LCA and LCC in this project, this information covers both the amount and the type of materials, but also all the associated costs related to them. This traditional, let's say, LCA and LCC questionnaire that we use typically in project is not sufficient in this specific project where we are looking at the digitization of the manufacturing process. So the way we decided to approach this in the PIONEER project is to make some questions to the partners who we consider experts in their field. When hypothetically you would design a new product and you would want to launch a new product, how many physical prototypes would you need to make, or how long would it take to test them, or how many defective products would you estimate that you have? These are not hard numbers. These are hypothetical numbers based on expert opinions from the project partners, so that we can quantify the benefits of the digital solutions that we apply. So I will come to my closing statements. It is not very easy. So I'm now looking at the limitations. It's not very easy to do this comparative assessment of the conventional and the new products in this project. Partially, because the conventional products are not actually produced within the consortium. So there is no partner that produces steel beams, for example, that we can get primary data from. So we need to focus on secondary sources. And of course, the technology readiness level is much different between the conventional and the new product. So we are talking TRL 10 for the conventional and lower TRL for the new product. Lifecycle assessment by itself cannot capture all the benefits of the project digital solutions. So, for example, the concept of being more adaptable to market demand changes is not something that I can quantify with LCA. That's not something that the LCA can give me an insight on. And there is also benefits from this digitization that are important, but are marginal in terms of environmental impact. So in the grand scheme of things, if I make 5 digital prototypes or physical prototypes or 10 physical prototypes, when I'm planning to produce millions of products at the end, then the impact is just very small, if you think about it. But I also think that there are opportunities, and specifically if you consider a holistic sustainability assessment. So LCA alone, the environmental impacts alone are not enough. But to capture the full benefits, we need the full, the 3 pillars of sustainability, which also includes the cost and the social LCA. And this will help us reveal the full spectrum of trade-offs and synergies, and therefore enable a more balanced decision-making in these types of projects. So that was it from me. And I will stop sharing my screen so I can also start seeing you.
Thank you, Roxani, for this presentation. Very exciting work you're doing in the Pioneers project. And also, I think, well, all of the three projects delivering the webinars are very aligned in the work that they're doing. But indeed, apart from LCA using all the different digital solutions that are available for modeling and simulation as well of the different products, is also greatly going to help SMEs in reducing waste, reducing cost, and also reducing time. So this is something that we, through this initiative, are also trying to stimulate and boost within the company's knowledge to be seeking for those types of solutions and to be implementing them in their processes. So thank you both for this excellent session. Thank you all to all the attendees as well. We're going to post our session also on our social media channels, and we are going to expect you for our final webinar, which is going to be on the 3rd of July, and it's going to be focusing on digital twins and AI for small and medium-sized enterprises. So thank you all for your time, and I'll see you soon. Bye.
Bye.
Bye.